In this episode, we start building the foundation skill that quietly controls how safe and useful an artificial intelligence, AI, system feels when you interact with it through language. A prompt is not just a question you type. It is the set of signals you provide that shape what the model tries to do, what it pays attention to, and what kind of output it produces. Beginners often blame the model when an answer is sloppy, risky, or confusing, but a surprising amount of quality and safety comes from the prompt structure itself. When prompts are vague, the model has room to guess, and guessing is where both errors and security mistakes grow. When prompts are clear, the model is more likely to behave consistently, and consistency is the defender's friend. The goal today is to make prompts feel like a controllable interface, not like a magical conversation, by understanding four pieces that work together: roles, instructions, context, and output constraints. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A prompt foundation starts with the idea that models respond to a hierarchy of signals, even when you cannot see that hierarchy directly. In a well-designed system, some instructions are treated as higher priority, like safety rules or organizational policies, while other instructions are lower priority, like the user's current request. The reason this matters in security is that attackers try to smuggle low-trust instructions that override high-trust intentions, which is the core pattern behind prompt injection. If you build prompts as a single blob of text, you make it easier for untrusted content to compete with your rules. If you separate different kinds of guidance, you make it harder for a malicious or confusing input to hijack the model's behavior. This is the same logic as separating admin functions from normal user functions in software, because separation clarifies what is allowed to influence what. Prompt foundations are really about building clear boundaries inside language, so the model has fewer opportunities to misinterpret who is in charge. Roles are the first piece, and they are best understood as a way to set intent and responsibility before the model starts generating. A role can describe who the model should behave like, such as a careful security analyst, a policy-aware assistant, or a cautious explainer for beginners. The reason roles matter is that they set expectations for tone, depth, and risk posture, and those expectations influence what the model considers a good answer. If you do not set a role, the model may default to being broadly helpful, and broad helpfulness can be dangerous in security contexts because it can slide into providing risky guidance or overconfident claims. A role also helps the model decide what kind of detail level is appropriate, which reduces the chance it will either overwhelm the user or leave out critical safety caveats. A common beginner misunderstanding is to treat roles as cosmetic, like choosing a voice, when in reality they function like a policy hint that shapes decision-making style. In secure prompting, roles are one of the easiest ways to tilt the model toward caution and verification. Instructions are the second piece, and they are the part of the prompt where you tell the model what to do and what not to do in a way that is unambiguous. Good instructions are specific about the task, the boundaries, and the success criteria, because vague instructions invite the model to fill in gaps with assumptions. In security, assumptions are where trouble starts, because assumptions can cause data to be disclosed, cause unsafe actions to be recommended, or cause the model to treat untrusted content as trustworthy. Instructions should also be written as enforceable rules rather than as wishes, because language like try your best can still lead to risky behavior if the model interprets the user's request as urgent or important. Another beginner misunderstanding is to pile on many instructions that conflict, which creates ambiguity about what matters most. A defender's approach is to keep instructions coherent and ordered, so the model has a clean path to follow. When the exam talks about safe behavior, instruction clarity is often the hidden lever that makes safety realistic. A subtle but important part of instructions is scope, meaning the prompt should define what the model is allowed to consider and what it should ignore. In practical terms, scope can mean limiting the model to provided context, limiting it to a certain domain, or limiting it to high-level explanations rather than step-by-step actions. The security value is that scope reduces the chance the model will invent details or wander into unsafe territory because it is trying to be helpful. Scope also supports confidentiality because it discourages the model from pulling in irrelevant information that might be sensitive or from making inferences that reveal more than intended. Beginners sometimes assume that more openness gives better answers, but in safety-critical work, openness often increases the chance of hallucination and leakage. A well-scoped instruction is like a well-scoped permission set because it narrows the reachable behavior space. When you design prompts with scope in mind, you are doing preventive security, not reactive cleanup. Context is the third piece, and it is where many prompt failures become security failures. Context includes the facts, constraints, and supporting material the model should use to answer, and it can also include conversation history or retrieved documents. The helpful side of context is obvious. Better context usually produces better, more grounded answers. The risky side is that context can contain sensitive information, and once it is in the model's view, it can influence the output in unpredictable ways. This is why defenders care about minimizing sensitive context and providing only what is necessary, because reducing exposure reduces spillover risk. Context also needs to be trustworthy, because if untrusted text is placed into context, such as attacker-controlled log strings or user-supplied documents, the model might treat it as guidance rather than evidence. A beginner mistake is to paste huge blocks of content and assume the model will automatically separate signal from noise, but noise can drown out constraints and can push important instructions out of the effective context window. In secure prompting, context is powerful, so it must be curated. Context quality is not just about including information. It is about structuring information so the model can use it without misreading it. If you provide context that mixes rules, examples, and raw data without separation, you increase the chance the model will treat an example as a rule or treat raw data as an instruction. In security settings, this is how internal documents can accidentally become prompt injection carriers, because a document might include language that sounds like commands. A defender's approach is to clearly label context as reference material and to separate it from the instruction layer, so the model is guided to use it as evidence rather than as authority. Another context concern is completeness. Incomplete context can cause the model to guess, and guessing can produce confident but wrong output. The safest pattern is to include enough context to support accurate reasoning while also instructing the model to acknowledge uncertainty when context is insufficient. This keeps the model from filling gaps in ways that can mislead humans or create risky actions. Output constraints are the fourth piece, and they are where you turn a good intention into a predictable product. Output constraints define what form the answer should take, what it should include, what it should avoid, and how it should handle uncertainty. In security work, predictable output reduces risk because it reduces variance, and variance is what attackers exploit and what operations teams struggle to manage. Constraints can include requiring the model to state assumptions explicitly, requiring it to separate facts from inferences, requiring it to avoid sensitive details, or requiring it to provide a conservative recommendation when evidence is incomplete. Beginners often skip constraints because they feel restrictive, but constraints are actually what make a model reliable enough for repeated use. Without constraints, the model may change style, depth, and caution level from one interaction to the next, which makes governance and quality control difficult. A defender thinks of output constraints the way they think of secure coding standards. They are guardrails that keep outcomes within acceptable bounds. One of the most important output constraints in security contexts is requiring the model to be clear about what it knows versus what it is assuming. Models can produce fluent explanations even when they are uncertain, and that fluency can mislead users into treating text as verified truth. If you constrain the output to include uncertainty statements when evidence is missing, you reduce the chance of confident fabrication becoming operational action. Another constraint that helps is requiring the model to explain the reasoning at a high level without revealing sensitive details, which supports accountability while avoiding disclosure. Constraints can also restrict the model from giving step-by-step harmful guidance, focusing instead on safe, high-level concepts and policy-compliant behavior. The key is that constraints should match the risk of the use case. The higher the impact of being wrong, the stricter the output constraints should be. This is how prompt design becomes risk management, not just communication style. Exam scenarios that involve safe assistant behavior often hinge on whether constraints exist and are enforced consistently. Roles, instructions, context, and constraints work best when they are aligned rather than fighting each other. If the role says be cautious and policy aware, but the instructions say be maximally helpful, and the context includes untrusted content, the model receives mixed signals and will behave inconsistently. In security, inconsistency is a vulnerability because it creates edges that can be probed, like asking the same question in different ways until the model slips. Alignment means the role supports the instructions define how to use the context, and the output constraints enforce the desired posture. A beginner might think the model will automatically reconcile conflicts, but conflicts are exactly where unpredictable behavior appears. A defender therefore designs prompts as a coherent system, not as a pile of requirements. This is also why prompt templates become important later, because templates preserve alignment across repeated use rather than relying on each user to reinvent structure perfectly. Good prompts are boring in a healthy way, consistent, controlled, and hard to misunderstand. A practical way to see prompt foundations as security controls is to compare them to traditional controls you already know. A role is like a job description that defines duty and intent, which parallels the idea of roles and access control. Instructions are like policies and procedures that define allowed actions, which parallels governance and least privilege. Context is like data access, which parallels the need to limit exposure and to validate sources. Output constraints are like guardrails and logging formats that keep behavior auditable and predictable. When you frame prompts this way, you stop treating prompting as a soft skill and start treating it as part of system design. This framing also clarifies why prompt failures can become security incidents, because a prompt is part of the control plane that guides how the model interacts with data and users. If the control plane is sloppy, the system is sloppy. If the control plane is disciplined, the system is more resilient to mistakes and manipulation. A major beginner misunderstanding is to assume that if you tell the model one safety rule, the rule will always hold, regardless of what else appears in the conversation. In reality, models are influenced by the full context, and context can include persuasive or conflicting text that pulls behavior away from your intent. This is why instruction hierarchy and separation matter, because they reduce competition between safety constraints and user-provided content. Another misunderstanding is to assume that more context always helps, when excessive context can bury the constraint signals and increase the chance that sensitive information appears in the output. A third misunderstanding is to assume that output formatting requests are merely aesthetic, when they can be security relevant by forcing clarity and limiting what can be disclosed. Defenders counter these misunderstandings by designing prompts that are minimal, structured, and explicit about trust. If something is untrusted, the prompt should say so. If something is sensitive, the prompt should restrict it. This is not pessimism. It is disciplined engineering in a language interface. Prompt foundations also connect directly to how you handle user intent, because many security failures start with ambiguous intent. A user might ask for help analyzing an incident, but they might also be seeking details they should not access, or they might be unknowingly repeating attacker-controlled content. A well-designed prompt can instruct the model to ask clarifying questions when the request is ambiguous, rather than guessing. It can also instruct the model to refuse or redirect when the request crosses a boundary, rather than trying to comply creatively. These behaviors are not just about policy. They are about reducing risk created by uncertainty. In many real deployments, the safest outcomes come from a model that sometimes slows down to clarify rather than racing to answer. A beginner might interpret clarifying as a weakness, but defenders know that clarity is a security control because it prevents mistaken disclosure and mistaken action. On an exam, when you see a scenario with unclear user needs, the best design often involves prompts that enforce clarification and safe defaults. Once you adopt this foundation view, you can also see why prompt design is never truly finished. As the system is used, you learn where users get confused, where the model drifts, where untrusted content appears, and where output variability causes risk. Prompt foundations provide the stable scaffold that you can adjust without changing the entire model, which is valuable because changing models is expensive and can create new failure modes. That said, prompt changes are still changes, and they should be validated the way defenders validate other controls, by testing typical use and abuse scenarios and watching for regressions. A disciplined team treats prompt templates and system instructions as versioned artifacts with change control because they shape system behavior at scale. This connects back to lifecycle thinking. Prompts, context strategies, and constraints evolve as part of the serving state and should have clear criteria for updates. If you treat prompts as throwaway text, your system's behavior becomes unpredictable. If you treat prompts as control surfaces, your system becomes governable. The most useful thing you can do with everything you learned today is to practice hearing prompts as a structured contract rather than as casual conversation. The role sets the posture, the instructions define the task and boundaries, the context provides evidence under trust rules, and the output constraints make behavior predictable and safe. When those parts are cleanly separated and aligned, the model is less likely to wander, less likely to guess dangerously, and less likely to leak information through careless phrasing. When those parts are mashed together, the model is easier to confuse, easier to manipulate, and harder to govern. Security AI Plus is not asking you to become a prompt artist. It is asking you to become a responsible defender who can design and evaluate language-driven systems with clear boundaries. If you can explain these foundations in plain language and apply them to scenarios, you will be able to choose safer answers consistently, because you will recognize that prompting is part of security architecture. A well-built prompt is not magic, but it is a practical, controllable way to make an AI system behave more like a disciplined assistant and less like a risky improviser.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.